Hello, I am Daniel Martinelli. I am part of Team 701, the Gong Squad in Rhode Island, and I want to give a brief presentation on getting started and brainstorming strategies in subsystems. So, a brief overview of what you're gonna learn today is like how to brainstorm, documenting brainstorming, research inspiration. You can design inspiration, stuff like that, and then designing subsystems. How to brainstorm. So first step in brainstorming, you gotta find your goal or problem to actually have a focus on what you're gonna do for brainstorming. So originally you're gonna have a goal that you define, and like what's your goal for the year for robotics. That is the most important thing to find. And then if, say, a subsystem is not working, you gotta find the problem to the subsystem before you can even start to brainstorm how to fix that subsystem. The next step is to define your criteria and constraints. So criteria do so some basic criteria you could have is like durability, reliability, while constraints is time. That is your most important constraint or criteria. If you do not have enough time, then it's probably not the best option to choose a certain design over another. And then generating ideas, define what do you want to do to achieve your goals, and maybe what idea ideas you can that can achieve your goals, and then evaluate which ideas are the best. You can use a decision matrix for this. Which are the most important? Is it within the time frame? Is it too complex? Like if you're in a robotics team beginning out in robotics, do not pick a design too complex. It's probably not the best idea. It'd take too long. Might not be the best coded, and it could be just too difficult. And can you combine your ideas into one to make a better idea for both of them? Documenting brainstorming. Uh, I highly recommend using like some sort of engineering notebook or like a Google document to note down what you brainstormed and what you did during the day, so then you can refer back to them and compare with others, and it will also be useful in your engineering portfolio to see how your ideas have developed over time. Research, design, inspiration. You can be inspired by uh, different robots based on like former years. Like you do not have to come up with a specific chassis design. You can choose to have a parallel plate chassis and maybe try to make a design on your own based on something of a parallel plate chassis. And also another recommendation that's not on here, if your team is like uh it's like a school team, then you can refer back to like the older team's designs to see how they worked. And the CADs, you can ask like whoever runs it for the CADs to see how it works. And then here's like horizontal linear slides that we used last year. Here's in a video that we can watch to extend out. They are using it for depositing. We used it to intake the samples last year, but it's also an inspiration. Like you can take inspiration, it's fine. How to design subsystems. So first, a subsystem, it's just a component of a larger system that is self-contained, which means it can work on its own, but it also works together with other subsystems, and one subsystem affects the overall system drastically. And in the case of this, the larger system is the robot. Uh, so some systems like may include an active intake, or this year for decode, it could be a shooter to shoot the balls into, I don't even know what that's called, into the area where you score. And also like drivetrain. And it's designing subsystems and making sure they work together is the most important. If they do not work together, your robot will not work. Basically, like they need to work together to have an effective robot. So in my opinion, the best way to design subsystems is a CAD software, just because it's a great tool for visualizing, creating, using precision. It's very efficient, and it's great for collaborating with others and having ideas onto one huge CAD document. Something I really recommend, having a huge document with like all of your ideas in it so that you can see what other people are doing. Or you can use a team folder on the CAD software. So there are multiple different CAD softwares, all of which are great. I'd recommend that you use the one that you're most comfortable with. It's probably the best. Like, if you have no experience in CAD, then maybe try out a couple, or like I use Onshape right here, but just use whichever one you're most comfortable with and like the most. Okay. How does that? So then, designing subsystems using CAD software, you will use both Part Studios and assemblies. Part Studio is where you design a component or a component of a subsystem, or just a subsystem in general. Through this, you can 3D print parts of subsystems, you can laser cut parts of subsystems, and uh, oh yeah, I forgot to mention that CAD softwares, you can use 3D printers. They're compatible with 3D printers, which is also really important because sometimes 3D printed parts, although not being very durable, they're very precise, and custom parts allow you to do whatever you want with your robot. And then assemblies are used to combine part studios into one assembly, so you can use an assembly to combine all your components of the subsystem into uh, into one subsystem, and then you can also combine your subsystems into one huge assembly, which models the whole robot, which is really useful for visualizing where everything goes on the robot. And I'd recommend you do this at the beginning of the season. And then, yeah. Ooh, I forgot. Okay, so I'll go into. Why did I click 2? So I'll go into some depth over here with these images and the CAD software. Oops, did I stop? No. Okay. Okay, I'll go on shape. Okay, let's just go on a basic Part Studio. Okay, so the first tool you're gonna want to use if you want to design a subsystem is the sketch tool. You can sketch base, so like there's rectangles, circles, arcs, polygons. For the polygons, you can choose any different side Yeah, how many sides can you go up to on here? It's very interesting. It looks like 17, but it's 50. Yeah, you can go up to 50 sides. You probably won't need that. Just use a circle at that point. There's spline tools. Some of these are not useful, like text tools, probably not useful for robotics. But like over here, mirrors very useful, linear patterns very useful, and then over here are all your constraints and your dimension tool. All of these are very useful just to use. So I'd recommend learning the software and getting used to each of these constraints, each of these tools up here. Then over here, so when you have a sketch, you can use all of these other tools up here, like the extrude tool, which can uh, it creates like thin parts, surfaces, like a 3D part with depth. So the sketch is 2D. Extrude tool allows to make it 3D. Revolve tool makes it circular. Sweep, loft. I'm not sure sweep's that useful. Loft's pretty useful. Fillet is very useful because you don't want to have sharp corners on your robot. So the fillet tool will help you have curved corners, which is better. Chamfer is pretty useful. Draft, it's okay. Then rib, probably not that useful. Shell's pretty useful if you want to use it. Then patterns, again, useful. It's just the pattern from inside there. Mirror, again, very useful. Boolean, it's the where you can union two parts or you can subtract two parts. I really like the Boolean tool, it's very good. Split, again. Split entities, also very useful, self-explanatory. Then transform wrap, it's not really that useful. Delete part, if you want. I don't really use it that much. Plane, creating an offset plane is really useful for your lofts and stuff. Then offset surface, it's pretty useful. Helix, not really. And then the rest, not that good. Is there anyone I'm missing? Okay. And then assemblies, you will have all of these mates up here. So these mate connectors are very useful. Fasten mates are just for fastening two parts together, and there's no degree of freedom between the two entities. Revolute mate is if you want the one thing to rotate around another. Slider mates if you want one thing to slide on another. Planar mates, sometimes it's you can have translation around along the x and y axes on one part, and it can rotate around the z. It's pretty cool. Then cylindrical mate is basically a combination of a revolute and slider mate. Then the last couple, like I don't think I've ever used a ball mate, honestly. It's kind of useless. But then replicate is very useful. And then I also like using gear relation a lot when you have multiple gear, like when you have gears on your thing. Like we used it for a gear call just to simulate, and it's pretty cool. Same with screw relation. Yeah, yeah, but it's your introduction to the part studio and assembly. And then that is going to be it. Thank you for listening, and goodbye.